my workshop. So today's video is going to be a continuation of the last two videos, and I intend to show you a little bit more in-depth information of how to change or how to obtain a 3D relief from a grayscale picture. Okay, so we go now to this dialog area here and choose toolpaths. Now this brings up many different types of machining strategies. Basically this is 2D or 2.5D for doing different types of cutting procedures, and basically this is all 3D tool paths or 3D cutting strategies. So what we're going to do, we're going to pick this one here, which is general 3D carving strategy. So we want to do the whole of the relief. So we've got that one chose, and there's many different ways that we can machine, and we can even change the angle of which we want to machine if we so wish, but we're just going to use a standard raster machining strategy. Now what that means is the tool is going to start here, it's going to run along here, it's going to gradually go down in, I'm going to go in 5mm at a time, and we'll set that up in the dialog in a minute. And it's going to run back and forth in the X plane and go all the way through, and then drop down another 5mm and take material out, and another 5mm and take material out. We don't need to bother about any of this. Leave it as standard. So now what we're going to do is we're going to select a tool, and the tool we're going to use is a 12mm end mill. Although we're in the aluminium section, it really doesn't matter, because we're going to set the tool up, the tool parameters up, what we require in wood. So we're going to select that tool. Now we go back into here. Maybe I ought to swing you over a little bit just so you concentrate on what I'm doing there. There we go. So we open this up now, and this is where we can select the speed and feeds of this particular tool. Step over 3.6mm. Wow. That's okay. It's a 12mm. It's a big tool. So I'm going to go 4 there because I want to get as much material out as I can. Step down. It's saying 6mm. I like going 5mm. Now this is the millimeters per second of cutting speed. Now my particular machine will cut quite happily at 80mm per second. That's only because I have operated the drivers for the stepper motors themselves, and the ball and screws. The standard machine would not do this, would not come anywhere near it. It probably wouldn't even do 50mm a second. It doesn't matter what the manufacturer says. When it comes down to actually machining, it just would not do it. Now it will. And more. So, just to prove a fact, I am going to put this at, I'll put it at 80. And I'll show you exactly how it'll cut. I'm using NC Studio as well, so I can actually run that at 120%. Now then, what actually happens when the tool is actually cutting, and you'll see this when we cut it. In this area of well, flat area where the Z is not lifted up and down as it would be in this area, what happens is it will from here to here, you'll notice that the tool will run at 80 millimeters a second. It will just go straight along, then it'll slow right up, come up over here, and then go back down, and then go speed up again. So that's what happens. What it's saying is it is the maximum feed rate possible in flat areas. When it's doing over you know, sort of a corrugation area, the actual 3D relief, it does slow up, because you have to take into consideration the Z-axis has to pull up and push down, as well as the feed going in the X direction. So the machine takes a little bit of time to actually compose itself to do that. So this is maximum feed rate. Okay, plunge rate 6 mil. We're going to speed that up too. You know, we're going to go to 30. So I'm making the X work, not only the X work hard, I'm making the Z work hard as well, fast. I can leave that because NC Studio does not control my spindle. Right. Nope, that's okay. We're going to put ramp moves in. That's a little bit too much. 10-degree ramp angle, that's okay. And we're going to go 45. 5 millimeters one way, 5 millimeters the other way. Okay, ramp start, it's going to start 5 millimeters over the 0 point, the top of the material. That's what this represents. And it's going to go at a 10-degree angle. Actually, we might even make that shallower angle. We might even go, oh no, 10 degrees is okay. We'll leave it at that. Okay, material setup. So this is where we say the size of the material, the actual depth of the material. In our case, it's 30 millimeter. And it's in the top. These are all set correctly. Material 0, Z0, is the top of the material, which is what we want. And the 3D model, right, in relation to the material, it's going to be in the top section. In other words, this darker grey area here, that is where the model is going to be. We don't want it down into the bottom of here, because otherwise we'll be machining it out of the back of the material. So this is all correct. It's even telling me the maximum amount of 3D picture and the minimum material that's left on the back. We're going to OK that. So now we're going to label this. And we're going to say this is cut 1, and it's a roughing cut, and it's a 12 millimeter end mill. I just abbreviate everything. As long as I can understand what it is, you know, you do it you write it your way, and we want to calculate it now. Boom. And there, well, there's something wrong there. It's done it in one cut. Notice it's done it in one cut. I'll show you where that is, because I didn't fill in this. Do multiple passes. Yes. Is it at the first pass? We're going to want that minus, because don't forget the zero, Z0 is on the top, so we're going to go underneath that with the first cut. So we're going to minus 2 millimeter, I think. And there's no need for us to fill in that. I could say minus 20. So we go, no, that wasn't minus, hang on, do that again. Do that with a minus 20. Okay, so we're giving it some parameters. We don't want it done in one cut. We want it done in, I think, about 4 cuts, maybe 5. And calculate now. Now you see it's doing the individual layers now. This is what I wanted to show you, the difference. And by me making a deliberate mistake, by leaving part of the dialog box, shall we say, left out, it shows you the difference. We don't want to do it in one cut, we want to do it in multiple layers to make it easy on the tool, and it's better all round. So that's that. So now we go into tool paths again, and we're going to do the whole relief now. So now we're going to do the finishing cut with a 3mm. And also all this is all okay. All is okay. Select the tool. 3mm ball mill. Ball nose there. And now we're gonna do the speed and feeds. Really speed and feeds, you are not going to really understand too much about the feed and speeds until you start using your machine, until you start busting tools or hardly cutting at all, and you will realize then what these represent and how to alter them and how the tool behaves, how the machine behaves, and what the end product cut will look like. You will only learn about speed and feeds really by busting tools, as we all have done. I'm just trying to give you an example of the type of speeds and feeds and what actually works in the material I use anyway. Obviously, if this was aluminium or brass or copper, they would be greatly reduced, because I can guarantee you will bust tools. So, step over, we are going to leave the step over at 0.3 of a millimeter, which is fine. We actually could go a little, we'll go a little bit more conservative than that. We'll go 2.5, which is very fine. Why I altered that is because what it does in these areas here on the edge of the wings and places like that, sometimes you get furring left. Well, you've only got to go in there and by hand remove it afterwards with a small bit of emery or whatever. But if you make this a finer step over, it reduces that a lot. So there's another tip for you. Step down. I'm going to take that to 2 millimeters. Feed rate 15 millimeters a second. Well, we can bump that up to 50. Actually, no, we won't. We'll do 60. I'll show you what this machine will really do. Plunge rate 30. Now, if this was controlled by my program, I would be altering this now, as I will now. So I'm going to put this at 24,000 RPM. Let's really go for it, because as I am running a very fast feed rate for the tool, you need to speed the spindle up, because you have to cut the material and evacuate the material very quickly. And because this tool is so small, you need to have it spinning really, really fast to do that. Okay. We don't want ramp angles, because this is going to be done in one cut. Okay, so this is the finishing cut. So, finishing cut, and it's 3mm ball mill, and we want to do it now. Okay, there you go. So what we'll do now is we will do a simulation. Now, simulation is down here. This might be a little slow. I don't know. Let's find out. Simulate all toolpaths. We want fast. Otherwise, it could take quite a time. Here we go. Boom, and it's done. Basically, what you see here is exactly within 99% accuracy. This is what you will get reproduced on the CNC machine. So there it is. That is it. That's what you'll get. And because I've made this, I think 275, that means I'm going to have a border around the outside, left of material untouched, which is going to become the frame. So basically, that is about it to how to modify, not modify, how to create a 3D relief from a grayscale picture and modify it with imperfections, or take the imperfections out. So the only thing I've got to do now is save the information to my thumb drive or memory stick, folders, okay, drop that down for a minute, and we come over here to save the toolpaths. So grab this one, and you can save it in many different codes. I'll just bring some up. If I scroll down through, the hundreds of different codes that you can, and for different machines that you can save it in. But we use G-code millimeters, which is the standard pretty well. And we want to save that, and we want to save that in my E drive. Here we go. That's from another job that I was doing. So this is okay. Cut one, rough in, and it's 12mm, and it's an end mill. And we're going to save that. Then we just, it's already selected, so we can move it back over here. Then we get the other one. You can only save one at a time with my machine. If you had a automatic tool changer on your machine, well, you can save them all over and then let Mark III sort it out. Ball mill. And really it's as easy as that. This one will take a little longer to save because it's a very, very, very long program. And it's done. So there we go. That's what we're going to end up with. So there you go. That is exactly how to take a grayscale picture straight off the net into ArtCAM, remove any imperfections, clean the picture up, make the tool paths, save them, and now it's ready to be cut on our machine. So the next video will be us cutting Pegasus on the machine in I think we're going to probably use pine. So I hope you've enjoyed this video today, and please subscribe, press like. There's a little red box down in the bottom corner down there somewhere. That'll take you to my YouTube channel where there's now nearly 160 videos. Basically what I do with this channel is I show you how to use CNC machines, the programs that run them, CNC conversion. I do a lot of wood turning. I also do metal turning as well, and occasionally we'll make a bit of furniture. So really there's something I think on my channel for most people. So I hope you join me for the next video, machining this, and it'll be closer to Christmas then too, I think. So from me now, it's bye for now.